Good afternoon, everybody. Hope you are enjoying gorgeous weather in Portugal. It's really great to see this weather. Hope we can keep this weather intact in the whole world. And that's why that's the reason we are talking about sustainability, which is a very important topic for everybody. I think the way we are moving, we need to be very cautious and very concerned. Now, my topic is slightly different. We are scaling in our data centers, our operations every day. We need to be aware of the sustainability and we need to be aware of the security. But I'll be talking about a very small, tiny piece of the entire puzzle, which is called firmware. And how it is so relevant, because it is sitting on the hardware. It's a root or fundamental entity or essential entity on a hardware to enable it, manage it, monitor it all the time. So it's good to talk about what is the critical role of this particular small entity inside a data center, the firmware, and how we can enable sustainability, scalability, and the security through the entire data center. Three challenges that we see today. Of course, sustainability, we talked about scalability and security. Brian just talked before me that things are getting disaggregated. We'll be seeing modular system. The reason for the modular system is for sustainability, one of the big reasons. When we have disaggregated systems, it comes now from different vendors and it is connected by different interconnect methodologies. Sometimes it could be high-speed internet, sometimes it would be optical interconnect, sometimes it would be PCI, but every component needs to be protected because all put together is the security of the system. So security is very important, that how we do the root of trust today and how we'll be doing root of trust in the future. But more important thing is the sustainability that we are facing every single day today. So let's see. Major reason for sustainability, one of the things is the carbon usage or carbon emissions that we are seeing because of the large data centers are put in place every single day. One of the thing is the embodied carbon. Of course, the operational carbon emission is there, but one of the major problem that we see is the embodied carbon, which is inside a server, in the chassis, in the PCB, in the hard drive, in the power supply, everything all together. Of course, every device, laptop, notebook, mobile, every device has that issue. Let's talk about the server side. Because firmware plays a major role there and how to enable the future generation architecture or the system which is geared towards this problem, solve this problem. Energy, power utilization is another problem that we see that it has to be implemented. A good PUE is the key for every operational data center in the future. Even if we see the normal usage of the power, there is something that we talk about terawatt these days. It's going there, right? The usage of power is tremendous. It's like a hockey stick moving forward because of AI servers, because of our highly demanded tasks or the workloads that we'll be seeing. Just as a comparison, where I live, state of Georgia in the US, the entire power usage of that state is lower than the hyperscale power usage today. So that's how we can see where it is going and heading to. Now let's take a systematic approach of the sustainability, right? Today, in the left-hand side, you will see that we have a standard rack. And the system starts from silicon, and then the platform, then the rack infrastructure, then the DC power distribution, and then DC cooling infrastructure, right? The traditional way of managing the system, which is a monolithic system in the left-hand side, which we know very well, today's servers, they are not sustainability optimized, okay? Now, right-hand side, what we should take a look, that where we should pay attention, at least from the firmware enablement point of view. The silicon provides us the power management and telemetry. Tremendous amount of silicon innovations going on, either in the chiplet architecture or in the new processor designs. Everywhere we see power management, power telemetries, all these things are coming inside the silicon. And firmware plays a major role to enable them, configure them, and monitor and manage them at runtime. Then the second thing is that monolithic server design or monolithic systems are not sustainability optimized. The reason is, whenever the server is decommissioned and the new server is replaced, the old server, we are throwing away, we are recycling a lot of carbon, because the embodied carbon footprint of new servers will replace the old, or the old servers will be wasted. What if we can keep majority of that old server and only change the portion which we really need to change for our efficiency, for our compute power, for our other tasks? So of course, disaggregated platform or the modular system, which is called DCMHS, which is a OCP initiative, that is one of the key elements for the sustainability. Then of course, the other infrastructure, cooling infrastructure, is important. Now, air-cooled systems are, majority of our deployment today is the air-cooled systems, but direct cooling as well as liquid immersed cooling is the future. It may start with direct cooling and then cold plate and then get into the liquid immersed computers in the future. These are the three areas firmware will play a major role in terms of monitoring, in terms of managing, and in terms of controlling the power budget, and all sorts of things. This is the specification that is driven by OCP. It's the most efficient way to address the embodied carbon footprint as well as the power utilization and efficiencies in the future. Instead of having a monolithic server, of course, it is disaggregated and it is modular. It has each individual blocks. 5 years, 10 years down the line, if we need more power for a particular server, we can only change the compute board. Or we can, because it is so much disaggregated and modular, we may actually detach during a runtime, we may actually detach a compute element and put an AI element on top of it because of the workload demand at that time happening, and saving power. And whenever we need the compute, then again we can attach the compute back and detach and power of the AI module. And that is the true nature of the composable data centers in the future, which will be happening in dynamic way. Now, DCMHS is the fundamental specification, and there are multiple elements to it. There is one component called DC-SCM, which is the data center secured control module, which hosts the firmware, the fundamental or foundational firmware of a platform, which is BIOS for booting purposes, BMC for the management, continuous monitoring and management purposes, and the security module, hardware root of trust, which is the root hub of manageability of the entire server. When it is modular, you can think of that main server may not come from one manufacturer anymore. It may come from multiple companies and can be integrated together by a system integrator. That means not one single entity is responsible for the security. So there has to be a root hub of security operation, whether it is an independent silicon or it is merged with a management silicon, is a different thing. It's an entity which has to manage and attest the security of every component, including the silicon on the system and the power supplies, FPGAs, CPLD, IO controller card, everything, because they will come from different vendor. Now, we see BMC, which is the baseboard management controller, which is an out-of-band management controller in this system, which continuously monitor and manages as an independent entity in the server. And in case of modular server, it becomes like a center of the universe in this case, because it is connected as an out-of-band way to power supply, IO controllers, storage, GPU cards, GPU modules, liquid cool elements, everything. And this is continuously, not just the monitor, but manages it. It has the ability to control the power capping the system based on the usage. It has capability as an out-of-band way to detach and attach composable systems. It has an ability to also manage the cooling, thermal envelope of the entire server. So BMC is a very rich management functionality within a server, and it is continuously managing and reporting back to the higher level, which is actually a centralized management software, which is residing in the data center that can have a web interface to the system administrator, or it can have a programmatic interface where a lot of scripts and the automation, AI, all these things can be built on top of it. Everything is industry standard. So from BMC to the centralized management software, it is IPMI and Redfish. These are the two technologies, are two terminologies that we use, how they talk to each other. And then also RESTful interface to both web, it's an HTML-based interface, secured interface, either in a graphical way or in a programmatic way that can be automated, that can be in a data center. So in terms of the management overall data center, if you think as a rack, it has a network. Network will be managed by the centralized management software using SSH typically. And then the PDUs are managed by SNMP today. And centralized management controller gets all these parameters and a rich parameters from each individual server from the BMC in all regarding all the components in that particular server, and it manages the power. It could be very complex in nature. For example, in a server, maybe the workload is not that high, compute workload, and then CPU can be throttled and save power during runtime. And those are the things done by BMC continuously, and that reports back to the centralized management. So overall, this is an end-to-end solution that you can think of, which our data center should be using for the sustainability purposes. Now, how do we scale this kind of operation? AMI, we build firmware, and we have three different categories of firmware. One is system firmware, BIOS solution, Megarack is the BMC solution, and Tectagon is our brand name for the hardware root of trust. Now, we have a very flexible solution to target all type of devices, from a hyperscale server to edge devices. And what we provide is building firmware as a scalable way through CI/CD pipeline and DevOps services, where you can control source control, automated testing, software bill of material generation, as a PCERT as a service, and signing as a service. All put together, this is how the ecosystem can scale these solutions. From the security point of view, this is the chain of trust. As I mentioned, the hardware root of trust is the key. It starts from there, and it goes all the way to the application. And hardware root of trust protects the hardware, first of all, and then the firmware resiliency. If anything happens to the firmware, it rolls back the firmware. And from hypervisor onwards to the application, the attestation service that we provide help in confidential computing and the other things that we can report back. We don't control too much, but we can report back all those things. We need a generic and a uniform firmware solution throughout the ecosystem. That's very important for us. Otherwise, there will be different type of firmware exist in this industry. This shows the overall the modular system, that how this scalable firmware can support it and can scale the solutions in the industry, where you can show up different vendors' compute boards and can make the solutions possible at runtime. I will just quick glance through all these slides because we are having only 30 seconds, but this is the data center's challenge today, that sustainability, reliability, manageability, and capacity planning, these are the most critical 4 things that we believe is happening in the data center. These are the challenges. And what we do from the AMI point of view, we have a solution called AMI DCM. It's a data center manager, which provides all 4 areas, and it provides solutions for that. It does a carbon footprint analysis. It also does a power capping of the systems, so you can actually manage the power and control the total power of the data center. This also provides the visibility or the intelligence by providing the rich data to the administrator. That is the first thing that you need to know how much power that you are using. You need to know how much carbon usage that you have, emission that you have in your data center. Then only you can control it. So it provides the rich interface as well as programmatic interface. It provides the entire telemetry to the data center administrators. Overall, this is probably the last slide. Overall, I can say that we have a solution, end-to-end solution, starting from the platform level, where all the disaggregated platforms, which starts from power, storage, compute, GPU, everything, where our scalable firmware, BIOS, BMC, and the root of trust are present. From there, if you see the entire tech chain going up, we have an end-to-end solution to manage the power through data center management software, which we call AMI DCM. We also have an attestation software, which is called AMI True, and then there are firmware services built into that, so you can orchestrate the firmware. You can actually deploy the firmware altogether. And so all are contributed to OCP. Our Aptio, Megarack, and Tectagon, we have contributed 2 years ago, and we are continuously making it, we upstream it every quarter. Let's build this community together. Please contribute there. We are very open to enrich this 3 firmware, scalable firmware. It's completely open. It resides in these locations of OCP GitHub. We have exciting contributions in upcoming months. Hopefully in next Global OCP, we'll have some exciting announcement. And saying that, please come and visit us at booth A21. We have exciting demo for security, as well as hardware root of trust, as well as the AMI DCM. Sorry that I'm over a little bit of time. Thank you very much. So any question? Yes?
Can you talk to the intersections between the dynamic firmware stack and OCP safe?
Good question. So our firmware that we have a commitment that it will be OCP safe compliant, and we definitely will make sure that all the dynamic firmware will be OCP safe compliant. We also, during the process of our firmware generation, we create a software bill of material, and that should be the discipline that we should all maintain. And to make sure, because now the components are coming from different parts of the world and different vendor, everybody should maintain that discipline, because for disaggregated component or the individual platform, it could be a processor board, it could be a GPU board, which is an UBB in this spec. Everybody should maintain the firmware software bill of material and signed version, so we can all maintain. And AMI has a commitment that all our firmware would be OCP safe compliant. Any other question? Okay. Thank you again. Enjoy the rest of the show.